Good day everyone. So today we're going to do simultaneous equations. But before we get to that, we need to know to solve linear equations. And well, we did a couple of examples of solving linear equations already. Let's just go through one more, right? So a linear equation has one solution. It has one unknown, therefore it has one solution, right? So for example, we would have, let's say we have 2x minus 4 is equal to 8, right? And you want to solve for the value of x. This is a linear equation because the highest power of x is 1, right? You have one unknown. You could only find one value of x here. So the first step is to carry across the negative 4 to the right hand side. It becomes positive 4. So 2x is therefore equal to 8 plus 4, right? Therefore 2x is equal, 8 plus 4 is 12, right? Therefore x is equal to 12 all over 2. So therefore our value for x is 6, right? So this is just a revision for solving linear equations. We did this already. Alright, now we're going on to simultaneous equation. Now what is a simultaneous equation? Well, let me give you a definition for simultaneous equation now. So a pair of linear equations with two unknowns, let's say x and y, has a unique solution. So the solution can be represented by another pair x, y. So basically, simultaneous equations, you are dealing with two linear equations, right? So for example, we have an let's put down a pair of simultaneous equations here. So let's say you have x plus y, and that is equal to 5. Then you have a next linear equation below. You have x minus y is equal to 3. Right? So you have two equations and you have two unknown. X is the unknown and y is the unknown. So you label them equations 1 and you label them 2. So basically you have two linear equations or a pair of linear equations, right? For simultaneous equations, right? And you need to find the value of x and y that satisfy these both equations, right? So let's do the elimination method first. So in the elimination method, we examine both equations and see if it is possible to eliminate a variable by either adding or subtracting like terms. Right? So what does that mean is that we look at the two equations and we look at and see, can we add these two equations and get rid of the y, or can we add it and get rid of the x, or subtract it and get rid of the x and subtract and get rid of the y? Either one, right? In this case, we will add the two equations, right? And if we add the two equations, we will get rid of the y's, right? Because if you're adding coming down equation 1 plus equation 2, you have x plus x, which will give you 2x, y plus negative y, so I put them back the plus y, and you're adding the negative y. That will be equal to 5 plus 3, which is 8, right? So, okay, so if you're confused about how I get our 2x, let me just write it in. So you're adding x and x, right? You'll get 2x. So you have y plus negative y plus negative y, and 5 plus 3, right? So x plus x is 2x, y plus negative y would be 0. They will cancel off, right? Because they basically have y, this plus and minus in the middle will give you a minus y is equal to 8. Right? So you have the y's cancel off there, you remain with 2x is equal to 8. Therefore, x is equal to 8 all over 2. Therefore, x is equal to 4. Right? So we get our value of x to be 4. How do we get the value of y now? Well, simple. All we do, and I'm going to write this next step in a different color, we're going to substitute this x is equal to 4 in any one of these equations, 1 or 2. I will use equation 1. So the statement you're going to write is sub for substitute x is equal to 4 into equation 1. So now you have replacing the x with the number 4, put back your plus y, and that is equal to 5. Now you're solving for y, so y alone remains on the left hand side, you carry across the 4, so it becomes negative 4. So it's 5 subtract 4. So y is therefore equal, 5 minus 4 is 1, so y is equal to 1. Right? And as said before, the solution can be represented by an ordered pair. So for example, you could put it like this. It would be x comma y. In our case, x is 4 and y is 1. Right? This is our solution here. Y is 1, x is 4. Right? And this is the elimination method. We eliminated one of the variable and then solve for the other and then put it back in one of the equations to solve for the next variable. Right? So this is our elimination method. Okay. So now let's do an example where the coefficient of x and y are different. Before the coefficient of x and y were the same, right? The number in front of x was 1 for equation 1 and 1 for equation 2. The number in front of y in equation 1 was 1. The number in front of y in equation 2 was negative 1. Right? Let's do a more complicated one. Right? So we have 5x minus 4y is equal to 7, and then we have 7x minus 2y, and that is equal to 17. So label them equation 1 and equation 2. We need to find our values for x and y. First thing first, if you add the two equations, are you eliminating any variable? No, you're not, because the coefficient of x and y are different in the both equations. So you cannot just add them or you cannot just subtract them, because you end up with a next equation with the two variables, right? Because if you say 5x plus 7x, you will get 12x. Negative 4y plus negative 2y, you get negative 6y. You end up with our next equation with two variables again. So what we do is, in order to eliminate x or y, alright, so let me eliminate x. In order to eliminate x, you look at the coefficient of x in equation 1, it is 5. So you multiply equation 2 by the number 5, and you look at the coefficient of x in equation 2, it is 7. So you multiply equation 1 by 7. Right? So we're going to write that in the next step here, right? So let's write the first one. So it's equation 1 by 7. So I'll put in that equation 1 by 7 will simply give you, this is not an equal sign, right? So it will give you um, 7 by 5 is 35. So 35x negative 4y times 7 will give a negative 28y. And 7 by 7 is 49. This is a new equation. So we calling this equation equation 3. Right? And now we are multiplying equation 2 by 5. So you have equation 2, which is 7x minus 2y is equal to 17. We multiply in 7 by 5, we will get 35x negative 2y by 5, we will get negative 10y, and 17 by 5, what you will get when you multiply 17 by 5? 85, right? So 17 by 5 is 85. Call this equation 4. Now, let's analyze this. Looking at equation 3 and 4 alone now, we can eliminate x because the coefficient of x is the same. It's 35, right? Alright, so as we can see, the coefficient of x is the same. It's 35. So we can subtract equation 3 and 4. So we say equation 3 minus equation 4. Right, so let's see. It's 35x from equation 3 minus 35x from equation 4. Put back the minus 28y from equation 3 minus the negative 10 from equation 4, which is negative 10, put that in brackets, is equal to 49 minus 85, right? So 35 minus 35 cancel off, you'll get 0. Put back your negative 28y. Negative and negative in the middle return to a plus, you would have 10y. That is equal to 49 minus 85, which is negative 36, right? So now it's negative 28 plus 10, negative 28 plus 10, which is negative 18y. That is equal to negative 36. So therefore y is equal to negative 36 all over negative 18. Y is therefore equal to positive 2. So now that we get y is equal to negative 2, we can plug it in into either one of these equations, equation 1 or 2, and solve for the value of x. I will use equation 1. So substitute y is equal to 2 into equation 1, right? And remember, equation 1 was 5x minus 4y is equal to 7. So write back a 5x minus 4, y is 2 in brackets, that is equal to 7. So 5x minus 4 by 2 is minus 8, that is equal to 7. 5x is therefore equal to 7 plus 8. 5x is therefore equal to 15. So therefore x is equal to 15 all over 3. 15 all over 5, I mean. Yeah, and that will give you x is equal to 3, right? So that's now. Alright, so yeah, let's plug in. Okay, so we get y is equal to 2, and we get x is equal to 3. Now, to see if you are correct, right? Let's plug in those values into our two equations, right? So the original equation I was given in the question was 5x minus 4y is equal to 7. This was equation 1. And equation 2 was 7x minus 2y is equal to 17. We call this equation 2. The values for x we get is 3. The value for y we get that to be 2. Right? Let's just go up and make sure. Yep, that was the values. So now let's plug in that value into equation 1. So we get 5 multiplied by 3, subtract 4 multiplied by 2. That is equal to what? Well, let's see. So 5 by 3 is 15. Negative 4 by 2 is negative 8. 15 minus 8 is 7. Right? Do you have 7 over here? Right? And 7 over here. So you know that it satisfies equation 1. Let's see if these two values for x and y satisfies equation 2 now. So you have 7, open bracket, you put 3, you substitute 3, minus 2, open bracket, you put 2, because y is 2. Let's see what this will equal to. So 7 times 3 is 21. Negative 2 times positive 2 will be negative 4. So 21 minus 4 is 17. You have 17 here. So it satisfies the both equation, therefore these values are correct. Right? That is just a way to check to make sure your values are correct. Right? So let me show you all a next method. It's called substitution method. Right? So say you have x plus 3y is equal to 7, and you have 2x plus 5y that is equal to 8. So the first step is to label them equation 1 and equation 2. Alright, so you say from equation 1, we make x the subject of the formula since it's easier than y. So it'll be 7 minus 3y. So that is the value of x from equation 1. So we'll call this equation 3 because it's now a new equation. So we say substitute equation 3 into the second equation, which is equation 2. Right? Right. So we're gonna substitute equation 3 into equation 2. So now you have 2. You're replacing x with 7 minus 3y plus 5y. That is equal to 8. So let's solve for y now. So 2 times 7 and then 2 times negative 3y. So 2 times 7 is 14. 2 times negative 3y is negative 6y plus 5y. That is equal to 8. So negative 6y plus 5y will be negative y. I'll carry across this positive 14 to the right hand side, so it's now 8 minus 14. Now 8 minus 14 is, oh, okay, minus y here. 8 minus 14 is minus 6. So therefore y is equal to positive 6. If negative y is negative 6, positive y is positive 6. Right? Now you plug in this value y is equal to 6 into equation 3. This was equation 3 here. So let's put in that value there. I'll put it in this color here. So you have x is therefore equal to 7 minus 3 times, well, y was 6. Right? So therefore it is x is equal to 7 minus 18. And 7 minus 18 is negative 11. So that's how we get the values for x and y. X is negative 11, y is positive 6. Right? If you have any questions, feel free to ask.